When the degree of P of X is greater than the degree of G of X, and this is some function, that means the graph will have a slant, also known as an oblique asymptote. So let me give you an example. Let's say I have x squared plus 2x plus 1 on the numerator, and I have x minus 3 in the denominator. Notice the highest degree here is a 2, and the highest degree here is 1. The numerator is just 1 degree higher. Whenever you have that, that means you're going to have a slant asymptote, okay? So when it's bigger on top by just 1, we're going to have a slant asymptote. All right, so let's look at some examples. I'm going to give you f of x equals 3x squared minus 7x over x minus 3. Do you guys see how the degree in the numerator is 1 degree bigger than that of the denominator? That means you are going to have a slant asymptote. The way we find the slant asymptote is we divide. We're going to use division. I'm going to divide these two. So here I'm going to do synthetic division. I have 3, -7, and 0. Those are the coefficients of the numerator. And then you set the denominator equal to 0 and you solve, giving you 3. Any questions on how we set this up? Okay, does everyone understand why I put a 0 here? Okay, it's because it's missing on here. Okay, so we're going to bring down the first coefficient, and then you multiply. 3 times 3 is 9. And then you add, you get 2. Multiply, you get 6. Add, you get 6. We started out with a quadratic, because this is a 2. So we're going to go 1 degree down, and it'll be linear. So this is your equation. That was just a remainder. This is your slant asymptote. 3x plus 2. Okay, so I went on ahead and put this information. You learned all of this part last week, how to find each of those. Remember x-intercept, you need to factor this. So I would pull out an x. Set this equal to 0. That's how I got this x-intercept. Set this one equal to 0. That's how I got this x-intercept. Set the bottom equal to 0. That's how I got the vertical asymptote. Right? Okay, so I just put on all that information in for you. I'm going to go ahead and graph these. So we said that the slant asymptote is right here. That means I'm going to start at 2, put a point. My slope is 3. So I'll go up 3 over 1, up 3 over 1, and the same way on the left side to continue the pattern. This is my slant asymptote. All right. Okay, and I'll go ahead and put in my other information. I have a x-intercept, y-intercept here, and 7/3, that's 2 something, so right here. And all right, so my graph, oh, and my vertical asymptote is at x equals 3. So right here. All right, so I'm going to need to go through those points that I drew. So I'm going to look like this. Because this will go this way, and that will go this way. So you'll be in the middle. That is what your graph will look like. Your domain, you cannot be that vertical asymptote, which is at 3, and your range. I'm not going to make you guys write the range because it's a little complicated, but it's basically this point. Everything below this point is included in your range, and everything above this point, because that's what your other part of the graph looks like, is included in your range. But I'm not going to let you guys, y'all don't have to worry about that. Okay, we're going to do another one together. Go ahead and look at the next page. We have f of x equals x squared minus 9 over x. Go ahead and factor and give me all of the information. All right, so if you factor the numerator, you should get x plus 3 and x minus 3. X is in the denominator, nothing canceled out, so that means there are no holes in this example. Okay, x-intercepts. You need to set both of these equal to 0, and then you solve it. So the first one, you'll get -3, and the second one, you'll get a +3 if you solve it. Y-intercepts, we're going to plug in zeros everywhere. So let's see what happens if we plug in a 0 everywhere. A 0 goes here, here, and here. Can I have 0 in the denominator? No, so that means there are no x-intercepts. You can't have 0 in the denominator. Okay, so now let's do vertical asymptote. Vertical asymptote, I'm going to set the denominator equal to 0, and that gives me 0. So that's where your vertical asymptote is. So I'll go ahead and sketch that on my graph. Your vertical asymptote is at x equals 0. Okay, horizontal asymptote. Which one is this one, guys? Big on top. Big on top, so that means it's none. However, since the top is just 1 degree greater than the bottom, we do have a slant asymptote. So I'll go ahead and do synthetic division. And you can only do synthetic division when you have a linear in the denominator. Okay, if this was a squared or something, you wouldn't be able to do synthetic division. Okay, synthetic division is only when you're dividing by a linear, just a single x. Okay, and the coefficient is 1, so that works out perfect. So I have 1, 0, -9. Does everyone understand why I put a 0 here? Yes, because it's missing the middle term, the x term. Okay, you set this equal to 0, solve it, you just get 0. So 0 goes out there. Break down the first number, multiply. 0 plus 0 is 0, multiply. -9 plus 0 is -9. So what I'm left with is this is your x plus 0. That's your remainder. That does not matter. We're not looking at that -9. So this is your equation for the slant asymptote, y equals x. So let's go ahead and graph that. Graph the line y equals x. You start at the origin and go up 1 over 1. That's your slant asymptote. And I'll go ahead and graph my x-intercepts. I have one at -3. I have one at +3. So get close to the asymptote, go through your point, close to the asymptote. Close to the asymptote, go to your point, close to the asymptote. That's what your graphs will look like.
You just like follow the asymptote.
So my domain, I know I can't be 0 because I have a vertical asymptote there. Your range is all real numbers. It goes forever down and forever up. All right, so you should have factored. And what did you guys get? Perfect. Thank you, Jimena. All right, nothing cancels out. So that means there are no holes in this example. All right, so vertical asymptote, you should have set the bottom equal to 0, and you got what? Good, -5. You set the numerators all equal to 0, and what did you get? Exactly, 7 and -1. Are there any horizontal asymptotes? No, because it's big on top. Okay, I'll put none. Y-intercepts, you should have plugged in all of the zeros. If you plug in zeros everywhere, this is 0, so you get 5 in the denominator. And you get -7 times 1, you get -7. So that's your y-intercept, 0, -7 fifths. Yes, these are being multiplied. So this becomes -7 times 1, which is -7. Okay, so I'm going to go ahead and plot what I have so far. So x-intercepts at 7, 1, 2, 3, 4, 5, 6, 7 right here. I have one at -1. My y-intercept is at 0, and then this is about 1.4. So I'm going to go between 1 and 2, negative 1 and 2. That's my y-intercept. And your vertical asymptote, I'll draw it in red, is at -5. Right here. This is my vertical asymptote. Okay, slant asymptote. Let's go ahead and figure that out. So for my slant asymptote, I'll have 1, -6, -7, and -5 on the outside. Did you guys get -11? Okay, this number doesn't matter. It's just your remainder. So this is our slant asymptote. It'll be x minus 11. So your equation is y equals x minus 11. All right, so I'm going to go down 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is right here. Now, if your graph isn't as big as mine, where you can go all the way down to -11, then you can just plug in numbers. So guys, for example, this is my slant asymptote. It's going to intersect eventually with my vertical asymptote. By the way, my graph will look like this. Close to that asymptote, go through my points. And you'll have another one. You can't see it, but if I were to scroll down, this would be your vertical asymptote, this would be your slant asymptote, and your graph would go like this. You'd have another one down there, okay? But it's off of the page. Now, for those of you guys who weren't able to graph the slant asymptote because your graph stopped over here or something, you could always just plug numbers in. So say I plugged in like a 5. What's 5 minus 11? -6. So go over to 5. 1, 2, 3, 4, 5. -6. 1, 2, 3, 4, 5, 6. Boom, put a point. Okay? You can keep plugging in numbers and getting more points, or you just know that the slope is 1. So you're going to go up 1, over 1 from each point. Make sense, guys? Okay, so that's how you can always graph, even if your graph isn't big enough. Okay, I'm going to pause here. I'm going to show you these graphs on Desmos. So I'm going to show you this graph on Desmos so you can see it. All right, guys, this is the equation that I just gave you. We were able to see this top one. The bottom one is way down here. But that's the shape of the graph. All right, so you guys sounds like you guys factored correctly. You should have gotten 2x plus 5 and 3x minus 2. And this is your denominator. Okay, so to find the x-intercepts, you set each of these equal to 0 and you just solve it. So I'll just solve one of them. You would add 2. So you get 3x equals 2. Then you would divide by 3. So you get one of them is 2/3. What's the other one? Yep, -5/2. Okay, so those are my two x-intercepts. In order to find the y-intercept, what do? I put zeros everywhere. This will become 5 times -2 over -1. So this is -10 over -1, which is 10. So your y-intercept is at 0, 10. Vertical asymptote, you set the denominator equal to 0 and solve. What did you guys get? Good, 1/2. There are no horizontal asymptotes because it's big on top. The degree on the top is bigger than the degree on the bottom. But there is a slant asymptote, so let's find it. Okay, so notice, guys, I do have a linear, but the coefficient is not 1. So I cannot do synthetic division here. I'm going to do long division. So what I'm going to do is I have 6x plus 11x minus 10 divided by 2x minus 1. So guys, 2x times what will give me 6x? Oh, thank you. There we go. I'm going to need 3x. We're going to multiply. I get 6x squared, and multiply. I get -3x. What do I do after this step? Yes, change the sign. Y'all remembered. 11 plus 3 is 14x. And bring this down. Okay, next. 2x times what will give me 14x? 7. So this will be a plus 7. I can just stop there. I get y equals 3x plus 7. That's my slant asymptote. All right, so guys, I'm going to go ahead and graph my slant asymptote. I'm going to start at 7 and put a point. 1, 2, 3, 4, 5, 6, 7. And I'm going to go up 3 over 1. I can also go the other way. So this is my slant asymptote. I have a vertical asymptote at 1/2, so I'll go ahead and draw that as well. At 1/2, here's my vertical asymptote. And I'll go ahead and draw my x-intercepts. I have one at 2/3, that's roughly 0.67. So I'm going to put it right beside 0.5 right here. And this is -5/2. This is about right here. And my y-intercept is at 10. 1, 2, this is 7, 8, 9, 10, right here. Okay, so let me go ahead and graph it. You need to go through your points. Go through your points. Goes that way. Goes through your points. That's what your graph would look like. So your range is all real numbers because it's going to go forever down and forever up. And your range, your domain, x cannot be that vertical asymptote, which is at 1/2. Okay, so this next one, you should have first factored So by setting the top equal to 0, both of these equal to 0, you can get the x-intercepts. So you'll get -3 for the first one and a +3 for the second one. Then set the denominator equal to 0. If you solve it, you'll get -2 for your vertical asymptote. Then plug in zeros everywhere to figure out the y-intercepts. So this will be left with the 3 times a -3 over a +2. So this is -6 over 2, which is -3. So that's your y-intercept, 0, -3. Oh, I'm sorry. This is a 9. 3 times -3 is -9. So I'll just leave it as -9/2. So this is -9/2. Is that what you guys got? Perfect. Thank you. All right. Horizontal asymptote is none. And then let's go ahead and find my slant asymptote. So this will be 1, 0, -9, -2's on the outside, multiply, add. You can keep going, but you don't really have to because that's your remainder. You only need this part. So this is your slant asymptote at y equals x minus 2. So I'm going to go ahead and graph my slant asymptote. I start at -2 and my slope is just 1. My vertical asymptote is at -2, so that's right here. I'm going to draw a line, a vertical line at -2. And then I'll plot my other pieces of information. I have x-intercepts. One's at -3, one's at +3. My y-intercept, this is roughly -4.5. So that is right. 1, 2, 3, 4.5 right here. Okay, so if I were to graph this, it'll look like this. Go through that point, go through that point. That's what your graph would look like. So your range is all real numbers. Your domain, x cannot be -2. And we did not cancel anything out, so there is no holes. Nothing canceled out, so no holes.